You called the function. It returned, but it wasn't finished. You step through the code. The function pauses, and the next line runs before it finishes. Same thread, same moment, but different order. Something gave up control. Every async function has an await. When it hits that line, the function stops running. But the loop keeps going. You know that. So where does the rest of the function go? It goes somewhere specific. And that somewhere decides what happens next. You write code in order, top to bottom. Await looks like it means stop here, wait, then keep going. That's what it looks like. But the system can't stop. Not for one function. Not for anything. If it paused, everything would stop. It can't stop. So it doesn't pause. It leaves. Here's what actually happens. The function runs line by line until it hits await. At that point, the function splits. Everything above already ran. Everything below becomes a continuation, scheduled later, as a microtask. The function doesn't freeze. It returns to its caller. What does it return? A promise. Not the answer, a placeholder. Now the loop is free, so it moves on. When the awaited value resolves, the continuation is queued as a microtask. The loop drains it, exactly like before. Same kitchen, same pass. The chef is making a dish. Step 1, step 2, and in step 3, it needs oven. But the chef can't continue without it. So the chef writes the remaining steps on a VIP clipboard and starts the next order. The oven finishes, the remaining steps become the next VIP order. The chef never waited at the oven. The pause kept moving. Async function logs A, hits await, splits, returns to the caller. Caller logs C. So you'd expect A, B, C. A, C, B. The function returned after A. It wasn't finished. B came back as a microtask. Now see the cost. Between the two halves of your function, the loop ran other code. State could change, data could shift. Something you checked before the await may no longer be true after. Your function resumes, but the world moved. The split is invisible, but the gap is real. The function left. The loop kept running. Await is not a pause. It's a yield. So you stop asking, what does await wait for? You start asking, what runs while the function is gone? That question is where bugs hide. Function runs, hits await, splits, yields to the loop, value resolves, continuation drains, function resumes. That's a full cycle. Split, yield, resume. Most developers never see the split. They write await and just assume the function waits. It doesn't wait, it leaves. And now you see where it goes. One more thing. You read a value. You await. When you return, it is different. Something changed it. In the gap. That gap is the most dangerous place in async code.